Hi, welcome to another episode of Ordinary Differential Equations. We are going to talk about the method of reduction of order. Let's go ahead and see what the discussion is about today. Method of reduction of order. In essence, is a way of reducing a second order equation to first order. And we know how to solve first order equation. You remember we had two methods, integrating factor and separation. So this method is going to be very attractive because we can appeal to something that we have already done. But of course it comes at a cost. What is the cost? The cost is that a solution must be given and we find another solution. So you might be asking, what do you mean by a solution? Let's go back to one of the lectures we had a couple of days ago. Remember we talked about solving a constant coefficient second order equation. That was rather easy. We made a classification for it. We had something called the discriminant, and based on what the discriminant was, we had three possibilities. In each of these possibilities, you see there are two functions involved. The most straightforward case, we get two roots of the quadratic equation, the so-called characteristic equation, and then we have two functions. These are referred to as two solutions of the differential equation. Sometimes they are called the fundamental solution set. But the important thing is that they are different from each other. For example, in this case, the exponents are two different numbers. Or in the other case, when the complex conjugates were involved, at the end we ended up with two functions. One of them was a cosine and the other one was a sine. And then we had the borderline case where we had a solution that had a polynomial in it and the other one which didn't. So what we mean by given one solution means, for example, given the green one and we want to find the blue one, or vice versa, we are giving the blue one and we want to find the green one. Same thing for all of these things. Well, of course, in this case, we already know what the solution is. So you might be wondering, well, why go and rehash something that we have seen? Well, method of reduction has application to other kind of problems, most notably the problems we looked at before. This type of problems where cases where the A, B, C were some constants. What we are aiming to do is to go after some of the problems where these coefficients are variable. There are functions themselves, but we still have the right hand side as a 0. Let's go ahead and do an example. We will see clearly as to what is involved here. So here the idea again is that I have a linear homogeneous equation. So here's the format of it. I am given one solution, either the green one or the blue one or something of the like, but not a trivial solution, and we want to find the other one. Here, let's go after an easy example that you already know how to solve, but just as a way of starting with something simple, I'm going to go ahead and solve this problem. Suppose we want to solve y double prime plus 10y prime plus 25y equal to 0, and we are given that one of the solutions is exponential of minus 5t. The question is, what's the second one? Again, this is a problem we already know the solution to, but it's good to go ahead and actually do a simple exercise at the beginning. Then we are going to up the ante and go after something more complicated. Complicated in the sense that the coefficients are not just numbers, rather the coefficients are now variable functions. So the method that we had for this does not apply. That idea of discriminant that we had before for that is not applicable to this one. We have to go after something else. Again, in this case, the hint is that we know one of the solutions, we are supposed to find the other one. These two functions are going to be called referred to as a y1 and a y2 or something like that. So the reason you see a 1 here is that this is solution number 1, and we want to find the solution number 2. Again, to remind you of this, let's go back here. It's like considering one of these things as a number 1 and you want a number 2, or vice versa. Okay, so let's go back and get started on the easy one. So we start with our equation, y double prime plus 10 y prime plus 25 y equal to 0, and from some source we know that one of the solutions is exponential of minus 5t. The question is, who is going to play the role of the second one? Or in general, we might be asked to find the general solution. General solution means you remember just what we saw, k times this plus L times the other one, or some other constants that you might have interest in. So here's a big revelation here. How do we get this thing started? The way the problem is started is to write a solution that we are after as a multiple of this function. That is, we write the y that we are after as a multiple of y1. No, that's a major insight. Why do we know how to get started like that? Well, that's the kind of thing that when you spend a lot of time in mathematics, this kind of ideas do come to you. So you have an aha moment, and then you go after a certain method. So right now we are learning that method. Let's see, how do we go about starting from here and finding the second piece of this puzzle? Well, what we do is that we take this and take a derivative of it, and second derivative of it, take this thing, plug it back here, and we are going to see that the miracle is going to happen, that the equation that we are going to end up with, the equation for v, is going to be quite a bit easier than the equation that we have right now. So let's go ahead and do that. So y prime, how do I take a derivative of this thing? I need to pay attention that I have a product here, so I have to apply the product rule. Let's go ahead and write the formula for y1 here to make it specific. So I write v, the other function is exponential of minus 5t, and remember we are multiplying v as a function of t with this function. So to apply the derivative rule, derivative of the first times the second plus the first times the derivative of the second. Derivative of this, we need the chain rule. Derivative of the exponent is minus 5, and then exponential of minus 5t. Now by this amount of space that I put here, I'm kind of implying on my mind that I'm multiplying them, but a second later I'm going to forget and I'm going to think that I'm subtracting these two. So to avoid that kind of a mistake, you have to put the second one in a parentheses. Or if you don't like the parentheses, you have to improve your writing. How do you improve the writing? You bring the minus sign in front. You typically start with smaller quantities first, then your variable quantities, and so on. So now there is no mistaking as to what is meant here. We are multiplying these items. Without that parentheses, it would have been taken as subtraction, and we would have misunderstood our own statements. Okay, now I have to take a y double prime. I have to repeat this process one more time. Again, I have a product here and here as well. So differentiating this one becomes derivative of first, becomes v double prime exponential of minus 5t. Now we have learned our lesson. When I take the chain rule, I put the minus 5 up front. Then I have v prime exponential of minus 5t. So these two are derivative of the first one. Now I have to differentiate the second one. Derivative of the first is going to be v prime. So I have minus 5 v prime exponential of minus 5t. And now derivative of this one is going to give me another factor of minus 5 times this becomes plus 25 v exponential of minus 5t. Okay, these are the three ingredients. I have to take these things and plug them back in this equation. Well, of this y double prime, I just need one of these things. Of y prime, I need 10 of these. And of the y itself, I need 25 of that. So I'm kind of combining these like a recipe. I need one of that. Now, before I write it, I pay attention that these two middle terms are the same. If you pay attention, it always will be like that. When you take a second derivative of a product, the middle term always doubles up. So I pay attention to that and make a little bit of simplification. So let me write my factors, 1 and a 10 and a 25. And then I have one of this thing, so let me make a box or a parentheses. And 10 of y prime, let me make a parenthesis for that. And 25 of the original, let me just make a parenthesis for that for sake of uniformity. So one of this one. So it's going to be v double prime exponential of minus 5t. 5 and 5 is a 10. V prime exponential of minus 5t. And then this is, well, 25 v exponential of minus 5t. 10 times this, so that is v prime exponential of minus 5t. And then this is minus 5v exponential of minus 5t. And minus 25 of the original, which is just v exponential of minus 5t. Now I want to simplify this. If you take a moment and stare at this, you'll notice that exponential of minus 5t is a common factor all over the place. So why not be smart and factor it all out so that our writing doesn't become as cluttered as this. So in this simple problem, we can take exponential of minus 5t and put it outside. Then I multiply 1 with all of the stuff, 10 by all of this stuff, and 25 by that, and write them here. So 1 times v double prime. Remember, we took that out. Minus 10v prime plus 1 times this plus 25v. This one 10v prime, and then minus 50v, and then another 25v. If you look at this for a second, it does look magical, doesn't it? What do you see? Go ahead and simplify this and solve it for me, okay? So clean it up. Clean it up. And solve the resulting equation. Okay, so time to get that pencil and paper out. Of course, what's happening is that these cancel, and this and that cancels this one, and I have exponential of minus 5t times v double prime is equal to 0. Of course, I have a product of two things equal to 0. At least one of them got to be 0. Exponential is never 0. So all that I get out of this is v double prime is equal to 0. Did you get that answer when you work it out? Okay. I guess everybody agrees that when you look at this equation and this one, well, this is a lot simpler looking at that one. So what we have done so far is that, well, I use this solution number 1, and I took my solution to be a multiple of this and find out that that multiple satisfies an equation that is a lot simpler looking than that. If you remember, we have already solved solution of v double prime equal to 0? Maybe you want to take a second and tell me what is the solution. So in this simple problem, you can just immediately tell me what v is. Huh? I hope everybody is can tell me what v is. But to explain the reason for the title of this lecture, reduction. Oh, where is the reduction here? You were saying that again. You were saying that we want to convert to first order. Where is your first order equation? So what we do is, to reduce this thing, we introduce yet another function, call it w. So this game looks a little bit like those Russian dolls. You open the one doll, there's another one inside of it, and you open that one, there is still another doll inside of it. So we had some auxiliary, we called it v. Remember, we wanted a y. From y we went to v, and from v now we are going to w. So it's a bit of going down a ladder, coming back up in that ladder. So you have to play that game. So what we are going to do is take w to be v prime. So if you're looking at the v double prime is w prime. So if you're saying v double prime is equal to 0, you are really saying w prime is equal to 0. Well, this was second order. This is first order. That's what we mean by reduction. Reduction, we mean we can make our equation look like a first order equation, a lower order equation. Well, what is the solution of w prime equal to 0? Well, in calculus, you know, if a derivative of something is 0, when that thing is a constant. So I call w to be, say, k, a constant. Okay. Now we have to start going back up the ladder, or putting these dolls back inside each other. So w is equal to k. So we go back up to who is v. We remember the v prime, we called it w. And w we found out that is k. So v prime is k. So derivative of something is a constant. What is that thing? So, well, that we go up the ladder now one more step. If I tell you derivative of something is 5, well, that function has to be 5t plus some constant. So here I write k times t plus some other constant. Let's call that constant L, just to go along with the tradition we have for this. Now I have v. Okay. Now original problem didn't have any v's in it. We were asking what's the solution of this equation. We are looking for y. We brought up v just to make things easier for ourselves. So in what manner? Y was v times the solution that was given. Y is v times exponential of minus 5t. So one more level up, y is v times y1, or v times exponential of minus 5t. So y becomes our v, which was k t plus L, that's my v, times exponential of minus 5t. If you multiply this through, you'll see what's happening. It becomes k t exponential of minus 5t plus L exponential of minus 5t. If you stared at it for a second, you see that here is my new discovery. I had started with this exponential of minus 5t. They had given this to me as y1, that I give you one solution in the expectation that is that you find the other one. Well, you might call this one the other solution number 2. So you might call this one y2, and the whole thing will be the general solution. Now when you are coming across this kind of questions on WebAssign, if you just enter that, it's fine. If it asks for the general solution, so let's make it clear. General solution will be a multiple of this plus a multiple of that. So general solution is k times exponential of minus 5t plus L exponential of minus 5t. If it asks for another function, it's perfectly fine to just write the green one. To make it simple, if you always write that, it's always correct. Okay, so we solved a simple case. Simple, why simple? Because we had done this thing already. We had already given a recipe for this kind of equations, and now we have given a little bit of a derivation for the recipe that we had provided before. Now let's go ahead to new territory. New territory meaning we are picking up an equation that we have not approached before. That's example number 2. So let me write that down here. So let's see. 2t y double prime, excuse me, 2t squared y double prime plus, I guess the next one was 3t y prime. Let me make sure. 3t y prime, and then minus y, and what we are handed is, excuse me again, that the solution number 1 is t to power of minus 1. So if you want to call it y1 is t to power of minus 1. So I want to emphasize that this solution, this equation is very different from what we had seen before. Let me just remind you again in this lecture the type of problems we had seen here. Sorry. These coefficients were just constant numbers, and then we made a characteristic equation and solved it, and we had a simple recipe. What we are facing now is that the coefficients are variable, and that requires a more sophisticated approach, and that's what we are doing here. Now, well, recipe is the same. The process is going to be a little bit more complicated. In what sense? Before we get down to the detail of it, here we got very lucky that the equation that we got was really simple. In more advanced problems in this section, this step is going to be more involved, and you have more work to do. Let's go ahead and see this example, see how it works. So we said we start with y to be say t to power of minus 1 times v, just like what we did here, or v times t to the power of minus 1. Either way is same thing. So y prime, what's the derivative? Derivative first times second. Again, you have to apply the product rule. So minus t to power of minus 2 v, and then t minus 1 v prime. Then I differentiate one more time. Derivative of this, minus times minus 2 becomes 2 t to power of minus 3 v. Then derivative of that times the first, so that's going to be minus t to power of minus 2 v prime. Now I have to apply product rule here again. Derivative of the first is minus t to power of minus 2 v prime. Derivative of second is going to be t to power of minus 1 v double prime. Let's clean this up. We said the middle always doubles up, t minus 3 v minus 2t minus 2 v prime plus t minus v double prime. Then how do we combine these three? Out of y, I want a factor of minus 1. Y prime, I want a factor that is 3t. And y double prime, I want 2t squared. So let's remember what we are multiplying each thing with. So to keep track of things, 2t squared, I'm going to put these things here, and then 3t, I'm going to put this one here, and then minus 1 times y itself in the last parentheses equal to 0. So let's just put the entries. This is 2t minus 3v minus 2t minus 2v prime plus t minus 1v double prime. 3t times that minus t squared v plus t minus 1v prime and minus t minus 1v. Okay, let's clean up. Multiply. 2 times 2 is 4, so 4t minus 1 v. This becomes minus 4v prime. This becomes plus 2t v double prime. Multiply these two, becomes minus 3t minus 1v plus 3t and t inverse are going to cancel. I have v prime, and then finally minus t minus 1v Okay, I hope you pause before I mention anything and you derive to this stage yourself. If you didn't do that without me prompting you, let me see if I can convince you to actually go ahead and clean this up. Take this equal, so pause this thing, clean this up, and tell me what is left. Okay. So what's the magic of this method? Of course, you notice what is happening here. If you take a look at multiples of multiples of v, excuse me, what do you see? 4t inverse v minus 3t inverse v minus t inverse v. These cancel each other out. And that is always guaranteed. If you apply this method in general, you will see that that term always cancels out. And what you're left with is v double prime and a v prime. So let's go ahead and write this. So I have 2t v double prime, and then these two combine with each other also, and I get minus v prime. Okay, so step 1, we took this equation. Given the fact that this is a solution, we went ahead, substituted this in this equation, and we ended up with this one. You agree with me? This is simpler looking at that because it doesn't have this term in it. But what do we do next, you think? So let me ask you, take a perhaps a 5-minute pause and see, well, what do we do now? It's a little bit of a maze. This method is a bit, at the beginning, it looks a bit intimidating by number of zigzags that you have to do to get it, but once you do it, you see it's actually very natural and straightforward. What should I do first? Okay, take a few minutes, perhaps go back, but maybe before you go back, just think by yourself, what was it that we did? Can you remember what we did? We want to do the same thing again here, but of course we expect a bit more complication. So give yourself 5 minutes perhaps, see what you will do, and then continue. Okay, what was the doll inside of this doll, or the next rung of the ladder? The idea was to take another function, w, and call it v prime. Well, then w prime is going to be v double prime. Why do all of this? Because when I go ahead, replace my v's by w's, I see my equation becomes 2t w prime minus w equal to 0. Well, in some sense, this is the punchline of this. The punchline is that this is What is the big deal about this? You said what? Yeah, the big deal is that this is the first order. That is, coming to this step, what we have achieved is reduction. Title for this lecture is reduction. We started with this question, which was second order, and we made it down to first order. Okay, so if you made it here, congratulations. Now, next challenge. Well, how do we solve that one? Well, let me throw it back at you. So we did this thing at the beginning of the semester, essentially. We essentially have two ways of solving this. Either one would be great. And so again, I'm going to invite you to become independent and go ahead and figure out what W is. After you have found what W is, figure out what V is. After you found what V is, figure out what Y is. You might be asking, anything else you want me to find? Well, yes, well, we expect that you do this. So we go back here and say what? This is, let's write it as 2t. It's first order. You can do it by separation. You can do it by integrating factor. Either way, let me do integrating, which was a very nice method. So we write it in Leibniz notation. We rearrange 2t dw dt is equal to w. The idea was to rearrange, so here's one way you can do it. So we get dt over 2t. So of course now you have differentials. You integrate to see what you get. So antiderivative of this thing is logarithm of w. Antiderivative of this one is logarithm of t. And then what else? What do I need? Of course, I need a constant. So let's say constant some a or something. Well, what is next from w? We want to go back to v, and from that back to y. So I do need my w. I need the w by itself. I don't want the logarithm of w. So what I do is that I exponentiate, of course. Exponential of logarithm of w is exponential of 1/2 of logarithm of t plus a. Sorry. So I exponential of logarithm is the input. This one you can write it as exponential of logarithm of t to power of 1/2. That is, take a 1/2 inside plus a. Remember the exponents, when you want to separate them, they turn into multiplication. Common mistake for the student to write addition here, but no, it's a multiplication. Okay, this one becomes t to power of 1/2 and then times exponential of a. Okay, next, to clean up and get rid of these absolute values, I say, well, if these are equal, then w is equal to either plus or minus, and this is t to power of 1/2, and then this is, let me write exponential of a here. Now I say, well, exponential of a is a constant times either or plus or minus will be some other constant which could be positive or negative. No restriction on this one. So I call that whole thing case to just reduce my clutter. So I said w turned out to be some multiple of t to power of 1/2. Okay, that was some achievement. Did you make it to this far? Let me ask you next question. What do we do next? So there were like 3 dolls, one inside the other one, and then we are putting it back and going back to the bigger doll. So what should I do next? Next is that w, remember what w was? W was v prime. So we go after v itself, figure out what v is. So w is v prime. V prime is kt to power of 1/2. Well, now it's rather downhill. I have derivative of a function. In calculus 1, we learn how to figure out the function itself. I take an antiderivative of this, becomes t to power of 3/2 divided by 3/2, and then plus a constant. Let's call this one, say, L. We didn't want V either. We wanted what? We wanted Y. Who was Y? Y was V times Y1. Y1 was given to us as t to power of -1. Let's see. We have hopefully not lost by y is v times t to power of -1. So here I get take the reciprocal of this thing, 2/3 of k t to power of 3/2 plus L, all of that times t to power of -1. I clean it up, so I get 2/3 of k t to power of 3/2 times -1 is 1/2, and then L t to power of -1/2. This is what y is. This is y general, if you wish to call it like that. So let's go back and see what happened. This is what was handed to me as one solution, y1. The other variable part, you can call this y2, or you can multiply it by any number and call it y2 if you want. So here is a nice designation. You can call that y2, and the multiple of 1 plus a multiple of another 1 will be your solution. Now if this 2/3 bothers you, you can take this whole thing, put it in a bag, call that coefficient A, coefficient B. So that would be a nicer way of writing this thing. Or since I guess we used A and B before somewhere, but you can say A means something new, or if you don't want to recycle your letters, you can say M t to power of 1/2. Customary to use two consecutive letters, but anything would do so long as you understand what it means to you. So y general is some multiple of t to power of 1/2 and some multiple of t to power of -1. Of course, you can write this to the radical of fraction. That would be totally up to you. So rather algebra driven method for solving an equation. Kind of looks like coming out of thin air, but there's a magic to it that helps us solve lots of equations. The main idea was, if you have one part of a puzzle, can you use it to get the second part of the puzzle? That was the idea. You have one hint from that, you want to solve the whole equation. Okay, I have a few problems related to this in your homework, and I hope that you do your best going through this step. Okay, until next time, good luck and God bless.